Hi guys! Today we're going to be continuing our unit on stoichiometry, and we're going to be talking about limiting and excess reagents and how to calculate those. So to introduce that topic, I'm just going to use an example again of baking cookies.
We like cookies.
We like cookies, and we know you guys like cookies. So, this is our cookie recipe. If you have 3 cups of flour, 2 eggs, 1.5 cups of sugar. I should add this up here now that we know what this little delta sign means. Bake those in the oven, and we end up with 1 dozen cookies. If I told you that you had 3 cups of flour, 6 eggs, and 2 cups of sugar, you would be able to tell me that we're going to use up all 3 of those cups of flour to bake this dozen cookies, but we have excess eggs and excess sugar. Now, the 3 cups of flour is what we call our limiting reagent, because it's the reactant that gets used up completely. It gets used up first, and it helps to determine the amount of a product that is actually produced. So it's telling us that 3 cups of flour is going to produce that 1 dozen cookies. Now, we're going to have leftover eggs and leftover sugar. Those are our excess reagents. They are reactants that are not used up, and there's going to be some that are left over when the reaction stops or it completes itself. So, in this example, like if I were to ask you how many cookies could we make with this, with these ingredients using this recipe, you would tell me that we would be able to make 1 dozen cookies. But how many eggs would be actually left over, and how much sugar would be left over? You would also be able to tell me that, because we're dealing with 3 cups of flour, 2 eggs, 1.5 cups of sugar. So if I start out with 6 eggs, 6 using up 2 eggs, I'm going to have 4 eggs left over. And I'm going to have 1/2 cup of sugar left over. Now, I know you're thinking, like, yes, we are all capable of figuring this out using this recipe and these ingredients. When it comes to chemistry and using our chemical reactions and our moles or mass of different reactants and products, you're just going to be doing the exact same thing with figuring out who's going to get used up first. That's our limiting reagent. What do we have left over? That's our excess reagent. How much excess reagent do we have? If you had only 1 cup of sugar, how would you determine the number of cookies you could make? Now, you see our recipe is asking for 1.5 cups of sugar. But now with your dimensional analysis skills, you could tell me what 1 cup of sugar, how many cookies that is going to make. So we're going to show you how using dimensional analysis, you can determine how much of a product we are going to end up with and how much excess reagent we actually use up. So if you want to write dimensional analysis there, thanks. So remember, limiting reagent is the one that gets used up completely. It's the one that controls how much product is going to be produced. Excess reagent is all of those reactants that are not used up and are left over when the reaction stops.
So let's see what this looks like when we're using a chemical reaction and moles. All right, so here's our reaction. We have 2 moles of sodium reacting with 1 mole of chlorine gas to produce 2 moles of sodium chloride. Now, if I have 6.70 moles of Na reacting with 3.20 moles of Cl2, which one is a limiting reagent and which one is excess? Now, the first thing I want you to notice here, the hint that you actually have to find a limiting reagent is that you have 2 measurements given, right? We can see that we have 6.70 moles of Na and 3.20 moles of chlorine. That's going to be a good hint that we're going to have to figure out which one's going to run out first. All right, so I've already kind of set this up for you, but let's look at the steps here. All right, the steps is that we're going to use dimensional analysis to go to the same product, okay? Dimensional analysis to go to the same product. I've set that up over here. We have 6.70 moles of sodium. All right, and we're trying to figure out how much product is formed. Remember, the product here is NaCl. So I'm going to use my mole-to-mole ratio. If I have moles of Na on top, I have moles of Na on bottom. I'm trying to figure out the moles of NaCl, okay? And if we look at how many moles of Na, there's 2. How many moles of NaCl? There's 2. So this is a 2 to 2 ratio, right? We cancel out our moles of Na, and we're left here, after we do the math, with 6.70 moles of NaCl, okay? Now, step 1 is dimensional analysis to the same product. So that means we have to do this to NaCl for not just starting with Na, but when we start with however much chlorine we have. So I'm going to do the same exact thing. I'm starting with 3.20 moles of chlorine, which is given to me in the problem, and I'm going to set up my mole-to-mole ratio. Moles of chlorine is on top, so moles of chlorine is on bottom. I'm trying to find the moles of NaCl, right, the product, so that's going to go on top. Now I have 1 mole of chlorine, to 2 moles of NaCl. 2 moles of NaCl. This is a 1 to 2 ratio, or 2 to 1 ratio. And I multiply that out, my moles of chlorine cancels out, and I'm left with 6.40 moles of NaCl. Now I have 2 amounts of NaCl that could be produced. Which one is accurate? Step 2, find the smaller answer. Its starting substance is the limiting reagent, okay? So if I have this much Na, I can produce 6.7 moles of NaCl. If I have this much Cl, I can produce 6.4 moles of NaCl. This one is less, right? That means that chlorine is my limiting reagent. This one's smaller, so the reactant I started with, chlorine, is limiting. So my limiting reagent here is chlorine. The limiting reagent is not NaCl. NaCl is a product, okay? So if Cl is my limiting reagent, that must mean Na is my excess reagent. That's the one where we're going to have some left over after the reaction happens. Now, how many moles of NaCl could be produced? I have 2 quantities here of NaCl. Which one could actually be produced? Well, step 3. Start all other calculations with the limiting reagent. That means, once we know which one is limiting, we are going to ignore entirely our excess reagent, okay? Na is our excess. We're going to ignore this, okay? We're looking at Cl2. If we have this much of our limiting reagent, this is the amount of NaCl that we're going to actually produce, okay? Because once the Cl2 runs out, this is how much NaCl is produced. So, how many moles of NaCl could be produced? 6.40 moles of NaCl, because chlorine is a limiting reagent. 6.4 moles, because Cl2 is the limiting reagent. Okay, that one gets used up first. All right, let's take a look at a slightly more difficult problem. And this one is a little more difficult because the last problem we went from moles to moles. This time, we're going from mass to mass, okay? A couple extra steps. So here's my reaction at the top. I have magnesium plus hydrochloric acid, 2 moles of hydrochloric acid, yields 1 mole of hydrogen gas plus 1 mole of MgCl2, magnesium chloride. If 5 grams of magnesium reacts with 6 grams of hydrochloric acid, what is the limiting reagent and what is the excess? Okay, now look at my hint. Read all parts of the problem before solving. So let's take a look at the next 2 problems. We're trying to find the limiting and excess reagent. What mass of hydrogen is produced? Okay, and how much excess reagent remains after the reaction stops? This is the one where it's very important. What mass of hydrogen is produced? That means, ultimately, we want this to be mass of hydrogen that we're left with, okay? Because the next problem asks us what mass of hydrogen is left. So we want to figure out a mass of hydrogen.
Yeah, we don't want to have to go to moles and then go back and do more calculations.
This is going to simplify the calculation.
Sometimes this might ask, what is the, not in this problem, but sometimes we will ask you how many moles of hydrogen are remaining, and then you wouldn't want to go all the way to mass. You're just going to compare moles to moles.
All right? So, let's see. We're going to actually do both of these problems to grams of hydrogen. Now, notice I have 2 products. You can pick which product you want to go to, but because this is asking for hydrogen, I'm going to hydrogen, all right? If it asks for the amount of magnesium produced, I would go to magnesium here, okay? So let's start. We have 5 grams of magnesium. That means grams of magnesium is going to have to go on bottom. And we're going to have moles of magnesium on top. We need to get into moles first before we can do anything. And if we look at the molar mass of magnesium, it is 24.31 grams for every 1 mole. And grams of magnesium crosses out. Now we're left in moles of magnesium. This is where we use our mole to mole ratio. We're going to go from the substance magnesium to the substance hydrogen. So we have moles of magnesium on bottom. What unit goes on top? Moles of hydrogen. Okay? And that's H2 gas, not just hydrogen, H2. Okay? We have how many moles? 1 mole of magnesium, 1 mole of hydrogen. All right? Now moles of magnesium crosses out. We're in moles of hydrogen, but we want to be in grams of hydrogen gas. So we put moles of hydrogen gas on bottom and grams on top. Now, what's the molar mass of hydrogen? 2.02 for every 1 mole of hydrogen. And if we cross out our moles of hydrogen, we are left with 0.415 grams of hydrogen. Okay, good. Now we're going to do the same thing starting with hydrochloric acid, our other reactant. So, grams of HCl goes on bottom, moles of HCl goes on top. Right? What's the molar mass of HCl? 36.46. And we know that that's per 1 mole. Grams crosses out. We're left with moles. Now, what's the next step? Mole to mole ratio. We're going to go from moles of HCl, which goes on bottom, to moles of hydrogen gas, again, that goes on top. We have 2 moles of HCl for every 1 mole of hydrogen. All right, moles of HCl crosses off. Now we're in moles of hydrogen. So moles of hydrogen has to go on the bottom. And this is moles to grams. So again, we have to look at the molar mass. The molar mass for hydrogen has not changed. It is 2.02 grams of H2 per 1 mole. Moles of H2 crosses out. And we're left with 0.166 grams of hydrogen. Okay. Now, step 2, which one is smaller?
Oh, yeah.
This one is smaller. That means our limiting reagent has to be the reagent we started with, which is HCl. Okay? So HCl is limiting. Right here.
Yeah, I'm just going to...
Oh. Yeah, box it. That's good. So HCl is limiting, and therefore Mg has to be excess. Okay? What mass of hydrogen is produced? We just figured that out. I'm just going to draw an arrow. That's our mass of hydrogen that's actually could be produced, right? Now, how much excess reagent remains unreacted after the reaction stops? So that's asking how much magnesium is left over. After we have 5 grams, how much do we actually use up? So what's left over? Our hint is start with the limiting reagent. Remember, always limiting reagent once we know what that is, and go to the excess reagent. Okay, so 6 grams of HCl goes on top. Grams of HCl goes on bottom. Moles of HCl on top. Molar mass of HCl is 36.46 for every 1 mole. All right, grams crosses off. Moles of HCl goes on bottom. And remember, this time we're trying to go to the excess reagent, which is Mg. So moles of Mg on top. We have 1 mole of Mg for every 2 moles of HCl. Moles of HCl crosses off. We have moles of magnesium now on bottom. And we're trying to find the grams. So grams of magnesium on top. And our molar mass of magnesium is 24.31. We do that whole calculation, and we get 2.00 grams of magnesium.
Used.
This is how much we use in the reaction.
That's how much is used up when we have our 6 grams of hydrochloric acid.
All right, so now we're going to use this. Given minus used equals the remaining.
So
we're given, almost out of time.
Yeah.
We're given 5 milligrams, or 5 grams. So we're going to start here, 5 grams of Mg. How much did we use up? 2 grams of Mg. So what's left? 3 grams of Mg. Notice that our beginning amount is coming from our original problem. This is what we're starting with. We calculated the used up amount through dimensional analysis. And we subtract to find what's left. All right, That's it. Sorry that's so long. See you next time.